Well, I did get the opportunity to run into Billings this last week to pursue what kind of lumber I was going to use for the slats on this apron. We had kind of a nice discussion about different options. These were initially Doug fir, and Doug fir has a Janka hardness of about 660. Now, maybe not all of you understand what the Janka hardness is. I'm not really sure I understand it fully myself. But it's when they take basically a 7/16 steel ball, the actual measurement is .444, and they watch the number of pounds that it takes to compress that steel ball half its distance into the wood. So pushing this steel ball into Douglas fir, it takes 660 pounds to push this ball half its thickness into the wood. So I was looking for wood and comparing Janka hardnesses. Poplar has a hardness of 540, so it's not quite as hard as what the Douglas fir is. Price also came into consideration. Poplar is about $3 a board foot. Well, this Doug fir that was available at this store was $8 a board foot because it was vertical grained fir. So we looked into some other options. One is ash. I have part of that ash here, but I didn't have enough for the whole apron, so I could have gotten some more of that. The Janka hardness on ash is 1,320 pounds. That's almost twice what the Doug fir is. I have some red oak here, and that hardness is 1,220 pounds. That's still pretty hard, so I asked them about maples. There's a hard maple and a soft maple. Well, the soft maple has a Janka hardness of about 850. So it's another basically 200 pounds harder than the Doug fir. But the price on the soft maple was $4.15 a board foot. A little more expensive than the $3 for the poplar, but the Janka hardness was sufficiently more but not excessive. So that's what I decided to do. I went with the soft maple to make these slats out of. So it was a combination of comparing the hardnesses and the cost per board foot. So if I were restoring this manure spreader solely for the purpose of being historically correct, of course I think I would have gone with the Douglas fir. But there are different things that factor in, and this brings up again the difference of value systems. My value system that it has to be equal to or better in strength, and cost is a factor. So the soft maple is going to stand the moisture probably better than the Doug fir is. It's almost half the price of what the Doug fir would be, and it's harder. So it should work well for the apron and for the use that I want this manure spreader to be. So I did actually count all these chain links that go down each side. I hadn't had an accurate count up till now to know how many slats that I needed. So as it turns out, I have 74 links on both sides, so I need 74 slats accordingly. So I did save 3 slats of the original slats that were in the best condition, and between these 3, as I measure total length, it comes out that I need 51 5/8 of an inch in length. The outside width of my frame is 54 inches, but I'm going to have a 3/4, or more accurately, a 13/16 board on each side for my sideboards. So if I factor in a 13/16 sideboard and I cut my slats at 51 5/8, that's going to be a 1/2 inch undersize, which will give me a 1/4 of an inch clearance on both sides of the slat to the sideboards. I have a couple of sideboards that are left here, and if I just measure these, they look like they're only about a 1/2 of an inch thick, which seems pretty narrow. But if I look at the ends, they also have some cleats on the end that have been nailed to the sideboard, very similar to the sheep wagon I'm working on. And you can see that these nails have been clinched over. Well, the wood shrinks, but the steel doesn't, so these nails will give me a pretty close measurement of what I need. And it looks like it's a strong 3/4, so I'm guessing that 13/16 will be just right. Well, on these old slats, this would be the top of the slat that would be actually carrying the manure, and they are rounded off on each corner, but underneath they have these notches cut out into them to accommodate these links. So they're going to sit about like so. Now I've drawn this out on a piece of paper that helps me see just why this has to be notched out. So if this simulates where my slat would be, this is where these links will have to sit. Put this bolt right in the center. Well, you see this needs to be notched out for this portion of the link. Then this other side, as it goes around the end on the cogs, you see it has to have a relief for this hinge to work of the following link. So I need to figure out how I'm going to put these notches on these slats to accommodate these links. So to cut the notches into these slats so that they'll fit these chains, what I did was I took these old ones and put my gauge on and figured out what angle that was, and it comes up that they are about 30 degrees. So I made a little jig to accommodate this 30 degrees. It's a pretty simple little jig. I just took a 2x3 and I cut these at 30 degrees, and then I have a couple more of 2x3s in the middle. So as it works out, I can put my slat in here and it will fit right from this point to this cross here, so it gives me a positive stop. And then I can put it up to my fence and it'll give me my inside measurement for this notch. So that lines up with this shoulder here, and then for this shoulder I put a piece of electrical tape here so I can kind of gauge how far back this edge of the slat needs to come to line up with my saw here, and then I can take out the center and give me this 30-degree angle that will accommodate those chains. Well, in this position, it only does one side of the slat, so I can do that on both ends. But I need to do the other side as well, and so I need to tilt this slat the other direction. So on my little jig, I shimmed it out so that it will come up against my fence. So I have to take that out, and then my slat can go the other direction. And with my fence, it will be up against this stop here and against my shoulder there. And I can run my inside shoulder, come out to my outside shoulder, and take out the difference. So instead of removing this shim each time I want to do every slat, I've decided that I'll do the whole bunch in this position, and then I'll remove my shim, and I can put my slat in the other position. Then I don't have to go back and forth and back and forth and back and forth, but I'll just do one position at a time for all the slats, like so, and then I'll shift and do the other position. So my setup will be a little more repetitive and hopefully a little more time efficient. So this slat will actually be this direction when it's on the apron. This is a portion that you'll see. And when this goes around the cog like so, these chain links have to bend this way. Well, these notches, like we looked at that diagram before, allows that to take place. These have freedom to move on both sides. Well, all these chain links get bolted right through the center with a 1/4-inch carriage bolt. You can see how the square is cast in for the head of the carriage bolt. And all these chain links are going to run on the center of these cogs. So I need to know what the center is from one side to the other. So that measurement seems to be 44 7/8. As I double check center to center on these old slats, they're also 44 7/8. So my overall slats are 51 5/8. Center to center is 44 7/8. So from the end, I'm going to come back 3 3/8. And then find the center. I'm 3 1/4 inches wide, so I am 1 5/8 to find the center. So I'd like to make this as repeatable as possible because I have 148 of these holes to drill. I've got a backstop and then a stop here that I can come in and drill my first hole. Now I'd like to be so convinced that my measuring is so accurate that I could just turn these slats around and use the same jig and everything would be exactly right. But I know I individually measured each slat and I'm not that accurate. So I have another little jig set up here. I have an extension on my table, and down on the end I put a little 1/4-inch bolt in there for a pin stop that I can put this hole in that pin. It'll sit right there, lock it into place. So from that pin to this drill bit, I've measured to be 44 7/8. So when I pin this slat in the hole that I've drilled on the other end, that's going to put that hole right at 44 7/8. And it will allow for any variations that I might have had when I cut these slats. So that should give us the proper distance hole to hole and allow for any variations. And that should allow me to drill a hole from either side of the slat. Well, 74 slats makes for a lot of steps to take it from rough lumber down to the finished material that we can go ahead and assemble onto the chains. I think I want to paint these before I do that assembly. I'll hook up the chains and put the rollers on, I think, this next week. Oddly enough, I wasn't aware of this until I visited with this Jeff Marshall, who is a descendant of these manure spreaders. These slats were yellow. I wouldn't have expected it, but he showed me some old pictures that seems to kind of verify that. We'll continue on next week and maybe get this put together. Thanks for following along.